Yeah, good morning all. Today I would like to discuss about superposition theorem. Okay, first we will discuss about statement of superposition theorem. Okay, superposition theorem states that in any linear bilateral network consisting of two or more sources, okay, the current or voltage across any branch is equals to algebraic sum of all currents or voltages when we consider each source separately. Okay, while considering each source separately, the remaining sources are replaced by their internal resistances. That is nothing but if the circuit is having voltage source, that should be replaced by short circuit, and if the circuit is having current source, that should be replaced by open circuit. Okay, to understand that one, let us consider a problem. Okay, from the problem only I will explain about that superposition theorem. Okay. Okay, let us consider a circuit. In the circuit, I need to calculate current flowing through 30 ohm resistor by using superposition theorem. Okay, 10 ohm, 30 ohm, 20 ohm, minus plus 10 volts, and plus minus 20 volts. Here I need to calculate current flowing through 30 ohm resistor by using superposition theorem. Okay, the statement of superposition theorem is in any linear bilateral network. See here, the given circuit is a linear circuit, right? The elements which are used in this circuit is bilateral elements, right? In any linear bilateral network, right? Total is a linear network as well as bilateral network consisting of two or more sources. See here it is having two sources, right? Then current or voltage, right? In this problem he is asking calculate current flowing through 30 ohm, right? That means current flowing through any branch. That means, for example, here assume current flowing through 30 ohm will be some I current. Okay, current flowing through any branch is equals to algebraic sum of all currents when we consider each source separately. That means first case consider 10 volt source is acting alone, calculate current flowing through 30 ohm, and the remaining source 20 volt source is replaced by short circuit. Similarly, second case consider 20 volt source is acting alone and the remaining source 10 volt source is replaced by short circuit, and again calculate current flowing through 30 ohm, right? Then total current is first case current plus second case current. Okay, that is nothing but superposition theorem. First we will solve one problem, then you have a clear idea. Okay, first case, for starting I am considering two sources acting alone. Okay, when we consider two sources, here I need to calculate current flowing through 30 ohm, right? To calculate current flowing through 30 ohm, I am using here nodal analysis. Step 1, identify the number of junctions. All currents are outgoing, I1, I2, I3, right? Okay, apply KCL at V. Okay, then I1 plus I2 plus I3 is equals to 0, right? All are outgoing currents. Then I1 is equals to potential difference V minus 10 by 10 plus I2 is equals to V minus 0 by 30 plus small I3 is equals to V minus 20 by 20 is equals to 0. Okay, if I take V as common, 1 by 10 plus 1 by 30 plus 1 by 20 is equals to RHS side 10 by 10 minus 10 by 10, you will get minus 1. If I take on RHS side, I will get 1 minus 20 by 20 minus 1. If I take on RHS side, you will get again 1, right? Then V into LCM will be 10, 20, 30, right? 60 is the LCM, you will get 6, 10, 6 is 60, 32 is 62, 23 is right, that is 2. V is equals to 120 by 11 volts, right? Then current flowing through 30 ohm is nothing but I2 is equals to current flowing through 30 ohm, that is V by 30, that is 120 by 11 into 30, right? That is 4 by 11 amperes. This is by using nodal analysis, right? After that, this current is equals to algebraic sum of all currents when we consider each source separately. Okay, by using superposition theorem, first case 1, 10 volt source is acting alone. Okay, now see here 10 volt source is acting alone, then the other source is voltage source, right? If other source is voltage source, that should be replaced by short circuit. If the other source is current source, that should be replaced by open circuit. Here we are having voltage source, right? Then that should be replaced by short circuit. That is minus plus 10 volts, 10 ohm, 30 ohm, 20 ohm, right? Again by using nodal analysis, first case I am assuming I1 dash, I2 dash, I3 dash. Okay, then I1 dash is equals to, assume node potential as V, right? Add this potential, apply KCL here. Then you will get I1 dash plus I2 dash plus I3 dash is equals to 0. I1 dash is nothing but here V minus 10 by 10. I2 dash value will be V minus 0 by 30. I3 dash will be V minus 0 by 20 is equals to 0, right? If I take V as common, 1 by 10 plus 1 by 30 plus 1 by 20, that is equals to minus 10 by 10, you will get 1, right? Okay, already we simplified this value here. It is V into 11 by 60 is equals to 1. Then V is equals to 60 by 11 volts. Okay, right? Node voltage completed, right? Then I2 dash is equals to V by 30, that is 60 by 11 into 30, 32s are right. That implies I2 dash is equals to 2 by 11 amperes, right? Okay, that is case 1, right? Next, case 2. What is the case 2? 20 volt source is acting alone. Okay, 20 volts source is acting alone. Okay, then 10 volts source is replaced by short circuit, right? Okay, now see here, this source will be replaced by short circuit. Plus minus 20 volts, right? It is 20 ohm, 10 ohm, 30 ohm. Okay, all values are correct. Okay, then again identify the number of junctions, apply KCL at junction V. Okay, at this second case I am assuming currents are I1 double dash, I2 double dash, and I3 double dash. Okay, apply KCL at that junction. You will get I1 double dash plus I2 double dash plus I3 double dash is equals to 0. I1 double dash is nothing but V minus 0 by 10. I2 double dash is nothing but V minus 0 by 30. I3 double dash is nothing but V minus 20 by 20 is equals to 0, right? If I take V as common here, 1 by 10 plus 1 by 30 plus 1 by 20 is equals to minus 20 by 20. I can take on RHS side, I will get 1, right? If I simplify this equation, 1 by 10 plus 1 by 20 plus 1 by 30 value will be 11 by 60, right? 11 by 60 is equals to V, and V is equals to 60 by 11, right? Then current flowing through 30 ohm will be I2 double dash, that is equals to V by 30, I2 double dash, that is V minus 0 by 30, right? V value already V value is 60 by 11, right? Substitute that value, 60 by 11 into 30, you will get 2 by 11 amperes. Okay, now see here, what is the value of I2 when we consider two sources acting alone? I2 is equals to 4 by 11, right? When we consider each source separately, I2 dash value is 2 by 11, I2 double dash value will be 2 by 11, that is I2 is equals to I2 dash plus I2 double dash, right? That is 2 by 11 plus 2 by 11 value will be 4 by 11 amperes, right? That is I2 is equals to I2 dash plus I2 double dash value, both are equal, right? That means now you can observe here, in any linear bilateral network consisting of two or more sources, okay, this is a linear network and bilateral two terminal network consisting of two or more sources, okay, the current flowing through any branch is equals to the algebraic sum of all currents when we consider each source separately, right? When we consider each source separately, remaining sources are replaced by their ideal elements. Ideal elements is nothing but voltage source should be replaced by short circuit. If the circuit is having current source, that should be replaced by open circuit. Okay, that is about superposition theorem. Okay, in this way we will solve problems on superposition theorem. Okay, thank you all.